Okay. So under the nomenclature of organic compounds, we'll start with a part called homologous series. If you talk about the series of any organic compounds, let's say the simplest of the organic compound, alkane. What's the molecular formula? Alkane are represented by
C++.
CnH2n plus 2.
CnH2n plus 2. So as I go on substituting the number of carbons, I get the first member of alkane as CH4, methane. Next one would be C2H6, ethane. Next would be C3H8, propane. Then it would be C4H10, butane, C5H12, pentane, and so on. Now, in this series of alkanes, if I talk about the two consecutive members, meaning ethane and methane, how many carbons difference do you see? Number of carbons differing?
1.
1. And number of hydrogen differing are?
2.
2. So basically, the two consecutive members here are differing by a CH2 group. Similarly, for ethane and propane, you observe a similar difference. Propane to butane, again a similar difference. And butane to pentane, CH2. So we observed that the consecutive members of any series of organic compounds differ by a CH2 group, which is called methylene group. And the methylene have a molar mass of carbon 12 plus hydrogen 1 into 2, that is of 14 units. So such series of organic compounds in which the consecutive members differ by a methylene group with a molar mass of 14 unit is called as homologous series. The series of organic compounds differing by CH2 is called as homologous series. So homologous series also have the characteristic properties which would be similar. So since they are represented by the same functional group, same molecular formula, they have the similar variation in the physical and chemical properties of organic compounds. Okay, so that's about homologous series. Next, under the nomenclature of organic compound, we have two ways in which they are named. One is the common naming system, which is also called as the trivial naming, meaning the old nomenclature which was used for few of the organic compounds. But all the organic compounds can't be given their common or trivial names. That is why there is alternate nomenclature which was named as IUPAC system of naming. So let's first discuss about the common or the trivial name. You can see a list of the organic compounds which have their trivial names. Some of them we are already well versed with. So, yeah. So if you look at the first compound, CH4, it is methane. Next one is the straight chain of 4 carbon atom, that is normal butane. Then a branched chain on the second carbon, isobutane. Two branches on the second carbon called as neopentane. So these are the 4 alkanes which we have already talked about. Then if you see the next one, it is a compound with 3 carbons and a functional group attached to it, that is OH. So OH refers to the family of alcohol, and 3 carbon chain which is attached to the OH is called as N-propyl. So from here we come to the introduction of the word alkyl. What are alkyl groups? So whenever an alkane, if we remove a hydrogen atom, then we get the corresponding group which is called alkyl. The name is simply given by replacing the word "in" by the word "yl". So the propane would change to propyl, ethane would change to ethyl, and so on. If I talk about the molecular formula, alkanes are represented by CN, H2N plus 2. Alkyl would be represented by CN, H2N plus 1. And also with the removal of hydrogen atom, one of the valency becomes free. This particular free valency or the unshared valency or the unsatisfied valency is now onwards referred as a radical. So what we get over here is an alkyl radical represented by a molecular formula CnH2n plus 1. So since there is 3-carbon chain arranged in a straight form, it is called N-propyl. With the OH, we have the name N-propyl alcohol. So we will discuss about the alkyl radicals in detail in the later part. Let's first discuss about the other compounds given. HCHO is the first and the simplest aldehyde called as formaldehyde. Then CH3 twice CO. This is the condensed form of CH3. CO is C double bond O and CH3. It is actually a ketone, and the dimethyl ketone is basically given a commercial name or the trivial name as acetone. Then we have CHCl3, which is a trihalide of one carbon called chloroform. Next is CH3COH, which we have discussed earlier also, acetic acid. C6H6 is the aromatic hydrocarbon called benzene. Now the next three are the aromatic compounds with some substituent. If you look at the first one, there is benzene, which is C6H5, and then bonded with a OCH3. This is the structural form. So benzene with OCH3 is called anisole. Next one is C6H5, meaning again a benzene ring, bonded with a NH2, which is called aniline. And the third one is, let me draw it over here, CO, that is C double bond O CH3 attached to the benzene. So this is an aromatic ketone which is given a name acetophenone. Acetophenone. So just remember the groups on the benzene. OCH3 is called anisole, NH2 group is called aniline, and COCH3 is called acetophenone. And last one, it's an ether compound with one side methyl and other side ethyl, hence the name ethyl, methyl, and ether. So this list of common or the trivial naming system you're supposed to remember by heart, because these are the important compounds which could be asked with their commercial or common or the trivial names. Fine. Now we come to the main part of the discussion, that is the IUPAC system of nomenclature. Now, if I talk about the IUPAC system, there are a set of rules which we are going to build up through the examples. And as we discuss the examples, we'll come across some important rules through which we can name any organic compound in the IUPAC system. So let's start with the first example. CH3, CH, CH3, CH2, CH, Br, CHOH, and a CH3. Okay. Now, if I ask you about the observation, how many functional groups do you observe in the given compound? How many functional groups do
Two.
you see? Two. One is the Br, which belongs to the halides, halogen family. Another is OH, which belongs to the family of
Alcohol.
alcohol. Now, under IUPAC, rule number 1 is to select the longest chain of carbon atom. Longest chain matlab it should have maximum number of carbons included in the chain. So if I talk about the number of possible chains over here, then I can have 1, 2, 3, one of the possibility, and 1, 2, 3, 4, 5, 6, another possibility. So of course, there are two possible carbon chains. One is of 3 carbon, other is of 6 carbon. The longest chain of the carbon would be of 6. So this is how we select the longest chain using the first rule. Now, the longest chain which we select for naming the compound is called as the parent chain. So this is the chain of 6 carbon with a single bond. So the parent chain would be called 6 carbon with a single bond would be called
hexane.
hexane. And as we discussed, the Br and the OH would be functional group, and the small carbon substituent which is not part of the parent chain would be called as a branch. Would be called as the branch. So from the rule number 1, after we select the longest chain of carbon atoms, we get two information. One is the information about the parent chain, and the other is the information about the child, which we also alternately called substituent. So it's simple, whatever is not the part of the parent becomes the child. The child can be categorized into two types. One is the functional group, which defines the properties of organic compound, and other is the carbon substituent, which we call it as a branch. And this carbon substituent as a branch is nothing but an alkyl radical, which I just discussed in the previous slide. So first we are going to discuss about the branch in detail, and then we'll come back to the rules so that we can name the compound. So now, when I talk about the alkyl groups, as we discussed, they are the radicals which are obtained by removing hydrogen atom from an alkane. So from the methane, if I remove the hydrogen atom, the first and the simplest alkyl radical which I get will be CH3. And the name of this would be methane minus H would give you the alkyl which is called
Methyl.
methyl. The methane minus H would give you methyl. Then from the ethane, after the removal of H, I'll get CH3CH2, or combinedly I can write C2H5 and would be called ethyl. They're also abbreviated by the first two letters of their name. Methyl is Me, ethyl is Et, propyl would be Pr, butyl would be Bu, and so on. So next, after the ethyl, I get CH3, CH2, CH2, and a radical. Also, I get CH3, CH radical, and a CH3. These two are both containing 3 carbon atom. So both would be called as, both are containing 3 atoms. So both would be called as
Propyl.
propyl. Next, if I draw some alkyl groups with 4 carbon, they all would be called 4 carbon alkyl would be called
Butyl.
butyl, and 5 carbon alkyl would be called
Pentyl.
pentyl. So I am just listing down the alkyl groups with the variable number of carbon atoms. Now, of course, from the propane, when I remove the H, I'm getting two variations of alkyl, which is propyl. But I can't name both the groups as propyl because they are different. And if they are different, we need to differentiate their names. So here, the names are differentiated with the help of something called as prefixes. So we are going to introduce the concept of the prefixes. Now, what are the prefixes? Prefixes are the differentiator which we use before the name. and they are decided by the type of the carbon, which can be primary, secondary, or tertiary. A primary carbon is that carbon which is attached to only one carbon. Secondary, attached to two carbon. Tertiary, attached to three carbon. So, if I observe the first propyl radical, this particular radical ka carbon is attached to how many carbon directly?
One carbon.
One carbon. So, as per definition, this is my primary carbon. Next, this CH wala carbon is attached to how many carbons?
Two.
Two.
So, it will be secondary. Now, quickly tell me other carbon atom. This radical carbon is
One.
one. So, primary. This one,
One.
one. So, again a primary. CH,
Two.
two. So, secondary. C,
Three.
three. So, tertiary. And this CH2 attached to how many carbon directly?
Two.
It's not two. This carbon is attached to how many other carbon atoms directly? The carbon has four valency. One is going to the radical, two are attached to the hydrogen. So how many is connected to other carbon directly?
One.
One. So this is also a primary carbon. Now if you observe all the primary, there is some common observation in every primary. It is always CH2 carbon. In case of secondary, your observation would be CH wala carbon, and the tertiary is C carbon. A primary is always a CH2 carbon. A secondary wala carbon is always a CH, and tertiary would be C. So that is a simple way to identify the type of carbon. Now, once you identify the type of carbon, then for a straight chain primary, you assign N. For a branch, you assign iso. For a two branch structure, you assign neo. If it is secondary, you just prefix sec, and if it is tertiary, you assign tert. So this is a simple way to identify the type of the carbon and then assign the corresponding prefixes to differentiate the names. So now let's apply this information to understand the names of the groups. So if I talk about first propyl ka variation, this one, it's a primary with a straight chain of carbon. So propyl to assign karna hi tha, but what is the prefix you will use along with this?
N propyl.
N. So it becomes N propyl. Next one is secondary. So you will prefix,
Sec
look at
propyl.
the table. So it will be sec propyl. But exceptionally, sec propyl is also given the name isopropyl. This is the only exception you have to remember with regards to propyl. Sec propyl is also named as isopropyl, and commonly we are going to use this name for the nomenclature. Next one. These are all butyl variation. The first one is straight chain,
N-butyl.
N-butyl. Next one,
Isobutyl.
it's a primary and it is a branch chain. So iso basically appears as a T shape and it is iso with four carbon called isobutyl. Next,
Sec butyl.
superb, sec-butyl. Next,
Tert-butyl.
it's tertiary with four carbon, tert-butyl. Next,
Neopentyl.
primary with two branches on second carbon, which is definition of a neo, And then with 5 carbon, it is called neopentyl. Are you clear with the list of the alkyl groups given?
Yes, sir.
You can please open the notes and refer to the flow of the session so that the things will be clear. Page number 16, you can refer. Okay. Now let's discuss the examples. So in the first example, A example, how many carbons you can select in the longest chain? So once again, thought process should be you identify all the possibilities of the longest chain. So if I start from here, 1, 2, 3, one possibility, 1, 2, 3, 4, another possibility. Reverse में, if I start from this CH3, then 1, 2, 3, and 4. But this possibility and the first straight chain possibility was same, because whether you go from this CH to CH3 or the down CH3, it's the same length which will be covered. And that's why there are two possibilities, out of which the longest chain will be of 4 carbon atoms. This becomes the parent chain. And whatever is not a part of the parent becomes a child or a substituent. And the carbon wala substituent is called as the branch. So basically, you have one parent chain and a single substituent which is called as a branch. What is the name of this branch?
Methyl.
Methyl. Now, once you select the longest chain, the next rule is to assign the number to the branch or the substituent. And to assign the number, the rule is you have to assign it in such a way that the branch or the substituent gets the lowest number. So simply the rule is called lowest numbering rule. You assign the number or number the chain such that the branch or the substituent gets the lowest number. If I were to number from left side, it would be 1, 2, 3, 4. The branch is coming at second. And from the right, if I had numbered 1, 2, 3, 4, the branch is coming at third carbon. Which is the lowest number assigned?
2.
2. Lowest is 2. So I will number it from the left hand side as 1, 2, 3 and 4. अब 2 पे जो methyl substituent है, along with the position, this is called as locant. Location of the branch or the child is at the second carbon. So we write it as 2-methyl, the child name or the branch name. And then the parent of 4 carbon with a single bond would be called butane. Hence, the IUPAC of the compound A is called 2-methyl butane. There are some simple rules which you are supposed to use during the naming in IUPAC. First letter is always capital. Rest all are small and it's a single word name. Number and alphabet is separated by a hyphen. If there were two numbers, then it's separated by comma. First letter capital, number alphabet separated by a hyphen, two numbers separated by a comma. So once you have understood these two basic rules, you should be able to name any of the compound in IUPAC. Now, next may tell me which would become the longest chain. How many carbons? Yes, how many
So
carbons?
we take it
Longest chain.
from the right side.
Okay, from the right side, the straight one.
And then we take ethyl, which is down.
Perfect. So thought process is you have to look at all the possibilities, and if you have observed carefully, you will get 1, 2, 3, 4. If you go in the straight chain, it will be 5. But if you go down, you will get 6 carbon. And that is the possibility of the maximum number of carbon. So this would be selected as the longest and the parent chain. So how many substituents or the branch did you observe? Whatever is not a part of the parent becomes a substituent. How many substituents?
2.
2. And both are
Methyl.
methyl. Now numbering. You do the numbering from right. 1, 2, 3, 4, 5, 6. You are getting 2 and 4. And if you start from the bottom side, 1, 2, 3, 4, 5, 6. You are getting 3 and 5. So as per this rule of lowest number, you will select 2, 4 or 3, 5.
2,
2, 2, 4.
2, 4. So this would be numbered from the right as 1, 2, 3, 4, 5, and 6. So this will be ruled out. And finally, the name would be given as 2, 4. There are 2 methyls on the second and fourth, hence 2, 4. 2 methyl together would be named as dimethyl. And the parent of 6 carbon will be hex with a single bond ane.
Hexane.
So 2, 4 dimethyl hexane would be the name. Understood?
Yes, sir.
Okay. So these are some alkyl groups which I have already discussed. From the methane, you remove a hydrogen atom, you get a methyl. From the ethane, ethyl, propane, propyl, butane, butyl, decane, decyl. Okay, here there are some more examples. So in the first one, longest chain would be of how many carbons?
5.
5. In fact, it's a symmetrical structure. You select the chain from the left hand side or the right hand side, you will get same carbon chain, and that will be of 5 carbons. So we have got the parent, and the 2 substituents are methyl. Numbering can be done from
Any side.
any side. The moment I say symmetry, matlab kahin se bhi number karo, you are going to get the same number. So can you tell the name? Yes, quick.
2,
pentane,
4 diamine.
Pentane is the parent and the child or the branch are 2 methyls. So complete name bolo.
2, 4 dimethyl pentane.
2, 4 dimethyl, and the parent of 5
Pentane.
would be pentane. Perfect. Next one, longest chain. Longest chain.
so the central line,
Central. How many carbons?
5,
5. So if you select 1, 2, 3, one possibility, 1, 2, 3, 4, 5, yeah, 1, 2, 3, 4, 5, the same possibility. So the longest chain is coming out to be with 5 carbon. But now how many child or the substituents did you observe?
3.
3. And all 3 are methyl, so we'll call them as
Trimethyl.
Trimethyl.
trimethyl. Perfect. And numbering should be done from which side?
Left to
Left or
right.
right?
to right,
Yes, because from the left hand side, you will get the positions 2, 2, 4. But from the right, if you had numbered 2, 4, 4. So lowest number is 2 to 4. And so finalize the numbering would be done from the left hand side. Now completing the name 2, 2, 4, 3-methyl combinedly would be trimethyl, and the parent of 5 would be called pentane. Got it?
Yes, sir.
Next one. How many carbon longest chain?
7.
7.
Okay. And it should be selected straight chain or in a
Straight.
L
Straight.
straight. So the longest chain is of 7 carbon and it is the simple straight chain. And now how many substituents again?
3.
3. This is one entire substituent called
Ethyl.
ethyl, and these two are methyls. Now, up till the previous examples, we were getting the child or the substituents which were identical. So 2-methyl clubbed as dimethyl, 3-methyl clubbed as trimethyl. But now the substituents are different. One is ethyl and other is methyl. So in that case, when the substituents are different, you have to use the alphabetical order. You have to name the alkyl groups in alphabetical order. But under the alphabetical order, you have to remember that the prefixes iso and neo are the only prefix considered in the alphabetical order, but the prefixes of n, sec, tert, even di, tri are all ignored while taking the alphabetical order. Meaning, if I have a name of an alkyl or a branch as isobutyl, which alphabet I need to pick up? Isobutyl का
I.
I, neopentyl का N, N-propyl या sec-butyl या tert-butyl. You have to pick up the first letter of the alkyl and not the first letter of the prefix. Likewise, if I have dimethyl, then the letter to be considered in alphabetical order will be M and not D. Similarly, triethyl ka alphabet to be picked up will be E and not T. So having remembered this simple rule, let's come back to the name. So in this, I have 1 ethyl and 2 methyl clubbed as dimethyl. So dimethyl ka which alphabet needs to be picked up?
M.
M. And the ethyl ka?
E.
E.
E. So ethyl would be coming first, followed by the dimethyl. So you are not selecting D. Otherwise, dimethyl का D पहले आता है, ethyl बाद में आता है, which would be wrong as per this rule of alphabetical order. Right? Now, numbering, if I say from the left hand side, I'll get 3, 4, and 4. Matlab position would be 3, 4, 4. And from the right, it would be 4, 4, 5. Of course, lowest number hoga from the left hand side. Hence, I finalize numbering should be done from the left side. So it's left to right. Okay. So now 2 pe the group is ethyl. So 2 ethyl. 4 pe there are 2 methyl. Hence 4, 4 dimethyl. These are all the child name. And the parent of 7 would be called hep with a single bond ane. Hence, the complete name is 2-ethyl, 4,4-dimethyl, and heptane. Got it?
Yes.
Next, look at this example. Here, the longest chain is already selected of 8 carbons. But what you observe is the two substituents, ethyl and methyl, are at equivalent positions. Equivalent positions mean if you number from the left hand side, you get the positions 3 and 6. If you number from right hand side, then also you get the positions as 3 and 6. So here I can say the child or the branch are located at equivalent positions. In that case, you have to number the chain as per alphabetical order. Meaning, जो अल्फाबेटिकल ऑर्डर में पहले आता है उसको नंबर भी पहले मिलना चाहिए. मतलब if ethyl comes before methyl in alphabetical order, the number of the ethyl substituent should also be lower as compared to the methyl. Is the rule clear? If the substituents are at equivalent positions, you have to number as per alphabetical order. Understood?
Yes, sir.
So in this case, the correct name would be 3-pe-ethyl, the lower number to the ethyl, 6-pe-methyl, and the parent of 8 would be octane. Whereas if you had written the name as 3-methyl-6-ethyl octane, it would have been wrong. So wrong क्या है वो भी ध्यान रखो so that the mistakes don't happen. Now, coming to the branched alkyl groups or the complex substituents. Complex substituents are those which don't have the common name possible for them. Complex substituents are those which don't have a common name possible. They don't have a common name. So in that scenario, we have to assign the IUPAC for such complex substituents. Let's take an example to understand. If I have CH3, CH, CH3, CH2, CH with a CH3 and a radical. So first observation, it's an alkyl radical. Totally of how many carbon? Total
6. 6.
6. Now generally, the alkyl radicals have the common name possible only up to 5 carbon atoms. Alkyl radical have the common name possible only up to 5 carbon atoms. So if you go beyond 5 carbon atoms, then the common name is not possible. In that case, we have to assign IUPAC name for the alkyls. So there is a simple rule for IUPAC naming of alkyl radicals. The rules are similar as we have discussed for the organic compound alkane. But उसमें छोटा सा twist है. Twist ये है कि here you are supposed to identify the longest chain, of course, of carbon atom, but the longest chain will be selected starting from radical, meaning the free valency. And the numbering doesn't follow any lowest number rule over here. It just says that you have to start the numbering from the radical. So basically, in alkyl radical, the nomenclature is simply focused with respect to radical. यानी radical से longest chain and radical से numbering is to be done. So if I ask with respect to this radical or the unshared valency, how many carbons can be selected in the longest chain? Starting from radical. How many carbons?
4.
4. Starting from the radical, you can have 1, 2, 3, and 4 to the bottom or 4 to the left. It's the same chain. And once we select the longest chain, the numbering is also to be started from radical. It means that radical wala carbon will always be getting the position
1.
1. So once I number, I observe there are 2 substituents or the carbon branch on first and third. So 1 and 3 पे 2 methyl है, you will club them and call 1, 3 dimethyl. And the parent of 4 as an alkyl would be called
Butyl.
Butyl. Hence, this complex substituent overall gets the name 1,3-dimethyl-butyl. Let's try some more example. If I have CH3, CH3, CH2 radical, how many carbons in the longest chain?
3.
3. Perfect. And numbering will be done from
Right to left.
right to left. In the next example, how many carbon in the longest chain?
3.
3. Again, from the radical, 1, 2, 3. And from the radical, numbering is also from right 1, 2, and 3. So here there is one carbon substituent. Here there are two carbon substituents. Can you complete the name of the first one? Yes.
2-methyl propyl.
2-methyl propyl. Perfect. And next one.
2, 2-dimethyl propyl.
Perfect. Good enough. 2,2-dimethyl, and the parent of 3 would be called propyl. So likewise, if you know the rules for alkyl radicals, you can just name any of the alkyl in their IUPAC as well. So with this information, let's move to some complex examples of naming organic compounds. Okay. So once again here, you have to apply the first rule of longest chain and then the numbering. So start analyzing and tell me how many carbons you can select in the longest chain. How many in the straight?
10,
10.
10. And I can go in the shape of Z also. See, 1, 2, 3, 4, 5, 6. Now from the 6, I can go down 7, 8. And from the 8th carbon, I can go right 9 or on the left again 9. And from the 8, I can go down and continue 9 and 10. So I'm getting the possibilities of 9 carbon, 10 carbon. Of course, the longest would be of 10 carbon. But here I'm getting two possible longest chain of same carbon atoms. So here we have to apply another rule. The rule is if there are multiple possibilities of selecting the longest chain. If there are multiple possibilities of selecting the longest chain, then the rule says select that longest chain which has maximum number of carbon substituents or branches. Then select the chain or the parent with maximum number of substituents or the branches. Now I'll give you a simple rule for identifying the substituents. If you look at the CH3 carbon over here, CH3, does it have any branch?
No.
CH2 carbon,
No.
CH wala carbon?
Yes.
Yes. How many substituent would we have on CH carbon?
1.
Only one. This is the entire substituent. And if you have a C wala carbon, then
1.
C pe nahi,
3.
nahi. This two radicals are part of the straight chain. Branches would be the ones which do not come in the parent chain?
2.
2. So with the observation, I'll just simplify this rule. If you have a CH2 or a CH3 wala carbon, then the number of branches will be equal to CH3 or CH2. Did they have any branches? I just discussed na CH3 and CH2. Did they have any branches?
No branches.
So I will call it as 0. Then when I have a CH wala carbon, if I come across a CH wala carbon, you will count as 1 branch, and a C wala carbon, you will count it as 2 branches. Okay, so let me analyze this example again. If I see the longest chain, I'm coming across one CH here and one CH here. So how many branches does this longest chain have from left to right?
2.
CH2 doesn't have a branch, CH3 doesn't have a branch, but the CH is having a branch. So I'll say there are 1 and 2, 2 branches. But if I go in this Z shape like this, then I'm coming across one CH and one C wala carbon. So how many branches would you consider for this longest chain? One CH and one C.
3.
CH pe there is one this entire big complex substituent, and C pe there are two substituent. That's what I have written at the bottom. That CH pe there is one branch and C pe there are two branches. Do you understand the circle part now? Yes?
Yes.
Yes.
Okay. So with this rule, the longest possible chain is selected with the maximum number of substituents. Numbering, of course, would be from the right side because the substituents are closer from there. So I will number it from 1 to 10. It's a decane chain. Now these two are the simple substituents जिसका नाम हमें पता है. 2 methyls would be dimethyl. But this one is a complex substituent for which I don't have a common name. So I have to use the complex substituent. I don't have a common name. I have to use the IUPAC. And the IUPAC naming of alkyl radicals is the longest chain should be selected from the radical, and the numbering should also be selected from the radical. So if I number it from the radical, then this becomes a substituent of the alkyl substituent, which is ethyl. And the name of this complex substituent is 2-ethyl butyl, which is one entire name to be written in parentheses. It's a single name to be written in bracket or parenthesis. Now, if I complete the name over here, then ethyl ka E and dimethyl ka M should be selected for alphabetical order. In that case, the fifth carbon pair, this entire substituent 2-ethyl butyl should be written as 5-2-ethyl butyl, 3,3-dimethyl, and the parent of 10 would be decane. So that is the complete name of this alkane. Understood?
Yes, sir.
Next one. Once again, identify the longest chain. How many carbons?
10.
10. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10. And is there any other possibility of 10 carbon or more than that?
No.
No.
So just if you analyze all the possibilities correctly, then you will be able to select the longest chain. So यहाँ पे तो एक ही possibility था of longest chain, so no issues. Had there been more possibilities of longest chain, we all already discussed the rule that you have to select that longest chain which has max number of substituents. So in this case, I come across two substituents which is up and down. Now these two substituents have a common name as well as IUPAC. So I can mention the name of this compound in two ways. Can you identify the substituent at the top? This is actually CH with a CH3, CH3. Look at the radical and try to name this. Radical pe focus. What was the CH radical called? I discussed about CH2
Sec.
primary, CH secondary, and CH tertiary. What was CH
Sec.
radical called?
Sec.
Sec. And sec with 3 carbon would be called sec
Propyl.
propyl. But exceptionally, this was called
Isopropyl.
isopropyl. And at the bottom also, the radical is on CH. Again, what is CH radical called?
Sec butyl.
This will be sec with 4 carbon atom, that is sec butyl. And I can also name this alkyl radical in the IUPAC. For that, I have to number from the radical. Number from the radical. So I've done the numbering. Can you complete the name IUPAC of isopropyl? Yes?
5 sec butyl 4 isopropyl.
No. I'm asking about isopropyl का IUPAC, not IUPAC of the compound. जो blue
Okay.
number की है ना मैंने 1 पे
Dimethyl propyl.
ना 1 पे there is only
Sorry,
one
sorry.
substituent.
हाँ वही sorry. Methyl. Ethyl.
हाँ 1 methyl ethyl होगा. 1 पे methyl है and the parent of 2 would be ethyl. sec butyl का क्या होगा?
1 methyl propyl.
Very good. 1 methyl propyl. So अब let's understand the final naming. And for that, I have to also do the numbering. Numbering is clear from the left hand side as per the lowest possible number rule. Okay. Now isopropyl and sec butyl mein, as per alphabetical order, isopropyl ka what you will select? I. And sec butyl ka?
S.
Nah. Sec butyl, sec is not considered. बोला था ना alphabetical order में sec third not considered. So sec butyl ka the alphabet you will pick up is
B.
B. Hence the complete name would be 5 sec butyl, then 4 isopropyl, parent of 10 would be decane. This is one name. Second, I can also introduce the IUPAC name of the alkyl radicals. Now in the IUPAC, I have one methyl ethyl and one methyl propyl. So methyl methyl to clash ho raha hai. So the alphabet will be selected based on E versus P, and E comes first. That's why it would be 4 pe 1 methyl ethyl in the bracket, 5 pe 1 methyl propyl again in the bracket, And then the parent of 10 carbon would be decane. These are the two ways of naming. Understood?
Yes, sir.
Yes, sir.
Next में longest chain.
Straight.
Sorry? How many?
9.
9. If you select from either sides, you are going to get the longest chain of straight carbon atoms, meaning 9 carbons. And how many substituents do you see?
1.
1. Do we have a common name of this substituent? Radical on CH2, primary, and 2 carbons branched on second carbon of the straight chain.
Neopentyl.
Perfect.
Neopentyl.
It's a primary with a 2 carbon substituent on second carbon, so it's neopentyl. And if I ask you the IUPAC of neopentyl, then we have done this.
2,2 dimethyl propyl.
Perfect. So now the name of this compound is simple. If you observe, there is a symmetry in the structure, meaning I can number from either sides. Neopentyl is occurring at
5.
fifth carbon. So it will be 5 neopentyl, nonane. या फिर instead of neopentyl, I can also write 5 पे 2,2 dimethyl propyl, and the parent will be same, nonane. Both ways the names are correct and acceptable. 5,2,2 dimethyl propyl, nonane. Understood?
Yes, sir.
Okay, then we have some cyclic compounds. So cyclic mein the simplest was alicyclic compound. So this is of 5 carbon atom, and the cyclic compound were named by a prefix cyclo, and the number of carbon 5 refers to pentane. So cyclopentane. So if I draw a cyclic ring like this, it's called
Cyclohexane.
cyclohexane, and there are 2 substituents on the ring. So this is 1 carbon substituent, methyl, and these are 3 carbon substituent called propyl. Now for cyclic ring, you have to always start from the substituent, numbering from the substituent. So if I number this as first carbon, then the other would be third. Vice versa, if I start numbering from this carbon, the other carbon will get the position 3. So can I say they are at equivalent positions with respect to each other?
Yeah.
And in case of equivalent positions, you have to number as per
Alphabetical.
alphabetical order. So methyl ka M versus propyl ka P, methyl comes first, hence the numbering is in the clockwise starting from methyl. And the naming will also be done with respect to that only, 1 methyl, 3 propyl, and the parent of 6 with a cyclic ring called cyclohexane. Likewise, again, let's say I have a cyclohexane ring with 2 methyls and 1 ethyl arranged like this. Again, they are at equidistant. Should I number them as per alphabetical order? Meaning ethyl first and then methyl?
Yes.
No, here there's a problem. Because if you look at the first carbon here, there are two methyls. So I would get the position, lowest number rule, as 113. But if I number from the ethyl starting 1, I would have got 133. Tell me which is the correct way to number.
113.
113. So from here, you should understand that the priority of lowest numbering is important than the alphabetical order. पहले आपको lowest number check करना है, फिर alphabetical order check करना है. So the numbering would be done from the methyl only, and it would be called 3-ethyl followed by 1,1-dimethyl, and the parent will be same, cyclohexane. That's the naming of compound. Understood? Any doubt up till here?
No.
Okay. Now, till the previous example, we have completed with naming of organic compounds having the carbon atoms joined by single bond, meaning we were focusing on alkanes. But now, once we introduce some heteroatom or some group which defines the properties of organic compound, we will be coming across the functional groups. Let's take an example. I have a chain of 4 carbon atoms, and let's say it is bonded with the OH. So here also you observe a carbon chain with single bonds, but what's new in this is the introduction of the functional group. So to name this compound in IUPAC, the rules are more or less similar, but with thoda sa change. So rule number 1 was longest chain. So here also you are going to select the longest chain of carbons, but containing the functional group. Meaning your longest chain must be containing the functional group. Then only that longest chain would be correct. Now this is a simple example. So of course the longest chain will be of simply 4 carbon atoms, and it is definitely containing the OH. So in this, once again, the longest chain will be called as the parent chain, and the one which is not a part of the parent is a child or a substituent. And now I'll categorize it as functional group. Second rule was lowest numbering rule. So in this, the numbering of the parent chain should be done such that the functional group gets the lowest number. The functional group gets the lowest number. So if I number it from the left hand side, 1, 2, 3, 4, the functional group is located at third. If I number from right, 1, 2, 3, 4, the functional group is located at 2. Which is the correct lower number?
2.
Hence, the correct numbering is from the right. Okay, now after application of two rules, longest chain and the lowest number, you write the name with the parent, that is butane. Then the functional group is alcohol. So we have a suffix used for the compound, that is ol, OL. And it's located at second carbon. So we write butane 2-ol by replacing the E of alkane by the word ol. You observe it carefully. Butane without the E. 2 is the location of the OH, and ol is the suffix of the alcohol. You can also write it as 2-butanol, but the more appropriate way of naming is butane 2-ol. Is this example clear?
Yes, sir.
Okay. Now, in the start of the IUPAC discussion, I introduced one example. It was CH3CH with a CH3, then CH2, CH पे Br, CH पे OH, and CH3. The observation here was the longest chain was of 6 carbons, but now it is containing how many functional groups?
2.
2. So there is a branch of methyl and there are 2 functional groups, that is bromide and the alcohol. So such case or such compounds are first of all called polyfunctional compounds. एक से ज़्यादा functional group है, we call them as polyfunctional compounds. Now for polyfunctional compounds, to name them in IUPAC, you need to decide out of the 2 functional group which is the main functional group. Out of the multiple functional groups present, which is the main functional group. And to decide the main functional group, we identify the priority order of functional group. So this priority order is determined by IUPAC, and this order is important to be remembered. So you can check your notes ka page number 21 and 22. Page 22 pe there is a table given with the compound name and the functional group. So as I write the functional group, you observe the functional group and tell me the class of compounds related with that. Okay? So the highest priority goes to COOH functional group. It belongs to which class of compound? Page 22 you can refer and tell
Carboxylic
me
acid.
carboxylic acid. Next one is SO3H.
Sulfonic acid.
Sulfonic acid, the last one in the table 8.4, page 22. Then COOR,
Esters.
esters. The R is a letter which represents the alkyl radical. So whatever alkyl radicals we have discussed, they are all represented by the letter R. Then you see COX.
Halides.
It's not halides. COX. थोड़ा सा नीचे जाओ. COX, COX. मिला?
HC.
Alkyl halides.
Acyl halides. ACYL. Acyl halides. These are some new functional groups which you haven't studied. So that's the reason the table reference is important. So COX is the acyl halide followed by CONH2. CONH2.
Amides.
Amides. Then CN.
Nitrile.
Nitriles. CHO.
Aldehyde.
Aldehydes.
Aldehydes. C double bond O.
Ketone.
Ketones. OH.
Alcohol.
Alcohol.
Alcohol. NH2.
Amines.
Amines. Now observe the difference. This was categorized as amides and this is categorized as amine. The difference is when you have a C double bond O bonded with a NH2, together it's a one functional group called amide. Do not say it's a combination of two functional group. One is ketone on the left and other is amine on the right. So amide is not ketone plus amine, meaning structurally you can remember it like that, but you can't say it is two functional group ka case, that is ketone and amine. Correct? So whenever they are together, remember the amide should not be said as ketone plus amine as two functional group. It's single functional group. Am I clear on this? Yes.
Yes, sir.
Then you have a double bond carbon called
Alkyne.
Alkyne.
alkenes and triple bond carbon,
Alkyne.
Alkyne.
alkynes. Then you have some functional groups which have the lowest priority in the order. These are X. What is X? The fourth one,
Halides.
halides, NO2, second last,
Nitro
Nitro compounds.
nitro compounds, and ROR,
E- ethers.
ethers.
compounds.
These are the three functional group which has got the lowest priority. So this priority order is also given on the page number 21, just previous page. So you are supposed to remember this priority order by heart. How to apply that we are going to understand over here. So let's go back to the previous example. So now this polyfunctional compound has two functional group. One is a halide, other is alcohol. Now refer the priority order and tell me out of alcohol and halide which gets the higher priority.
Alcohol.
Alcohol, because here you should observe the alcohol and this is the halide. Now from the priority order, what information do you get? Because the OH has the priority, we will now call it as the main functional group. And the other functional group of the lower priority would be just treated as a simple substituent. Now, on page 22, you can also observe the third and fourth column, which is the IUPAC group prefix and IUPAC group suffix. So if, as per the priority order, we have selected the main functional group, for that we will use the suffix of that compound, and for the other functional group, we will be using the prefix. So observe the alcohols and tell me what is the suffix of alcohol.
OL.
OL. And as a substituent, the BR would be called.
Bromo.
It's given as halo. Now, halo is a general name for fluoro, chloro, bromo, iodo. So of course, bromine होगा तो आप बोलेंगे bromo. ठीक है? And this carbon branch, we already know the name. It is a methyl branch. Okay, so I've categorized what to use when. As per a polyfunctional compound, one functional group of higher priority becomes the main functional group, जिसका suffix you need to remember from the table, and the other substituents, other functional group will be treated as substituents, जिसका prefix need to be assigned. Okay, so let's complete the name. For that I need to do the numbering. Numbering कहाँ से करेंगे?
Right to left.
Right side.
Because the functional group OH should get the lowest number. So from right to left. अब यहाँ पर दो substituents है. One is methyl, other is bromo. And since the substituents are different, we have to arrange them in
Alphabetic order.
alphabetical order. So 3 पे bromo, 5 पे methyl. This is the name of the child, followed by the parent, which is hex with a single bond, that is hexane, and drop the E replaced by all with the position 2. So that's the IUPAC name of the compound. Now observe, this nomenclature is same as you write your name. तो आप अपना नाम कैसे लिखते हो? First child का name plus hexane is the parent का name, child followed by the parent name, and all is the surname. ऐसे लिखते हैं ना, child plus parent plus surname. So first you introduce all the child substituents name, then the parent name, and then the main functional group, जिसका suffix will be the surname of the organic compound. Understood?
Yes, sir.
Now coming to some more examples. First of all, if you observe this formula carefully, it's given in a condensed form. So condensed form में कभी भी naming करना नहीं है. You have to first convert this into the structural form. So if I convert this into structural form, it's HOCH2 followed by CH2 repeated 3 times, followed by one more CH2. The CO is C double bond O and CH3. This is equivalent to the structural form of the condensed structural formula. So once again, for naming the compound, thought process. First, observe how many functional groups are there. How
Two.
many functional groups? 2. So it's a polyfunctional compound. So think about first is a polyfunctional compound. Second, you have to think about if it's a polyfunctional compound having more than one functional groups, you have to think about
Priority.
priority. So ketone versus alcohol, which gets a higher priority?
Ketone.
Ketone.
Ketone. So the longest chain would be selected with respect to ketone, and the numbering would also be done from the right side such that the ketone gets the lowest number. So now this becomes a child substituent जिसका prefix would be used. Look at the alcohol का prefix. क्या दिख रहा है? For the
Hydroxy.
table.
Hydrox.
तो 7 पे hydroxy आ गया. And ketone का suffix is on. So that's how the naming of this compound would be done. अब next example में, how many functional groups do you see?
1.
No? 2. What are the 2 functional groups?
Bromo and alkene.
Bromo and alkene. Even the double bond is the functional group. Now, bromo and alkene, which gets the priority? Halide versus alkene. Priority किसका ज़्यादा? Halide is X. Right? So now, numbering should be done from left or right. If the halide is of lower priority, numbering should be done from
Right.
right. So 1, 2, and 3. Bromo becomes a substituent, hence the name would be 3-bromo, prop 3 carbon, and then ene for the double bond positioned at 1. Complete name is 3-bromo prop 1ene. Next example, again it's given in the condensed form. So I will rewrite in the structural form, which is CH2 bonded to OH and CH2 bonded to OH. Observation, it's a compound where one functional group is repeated twice. So it's only one functional group compound but repeated twice. So for one functional group alcohol, we have a suffix -ol. But if they are repeated twice or thrice, we just added with a prefix di or tri. Hence, in this case, it becomes diol. And this is simply a chain of 2 carbon atoms. So with 2 carbons in the parent, this would be called as ethane. And one small rule to be added here, the E of the alkane is to be retained. E of the alkane is to be retained, hence it will be ethane 1, 2 diol. Next way, again if you observe, there are two double bonds. मतलब functional group एक ही है, but it's repeated twice. So as I said, for one double bond we write ene, for two you would be writing diene. And 4-carbon parent would be called but, and in this case, the A letter is to be added, meaning whatever is the word root, but or pent or hex, you have to name it as buta, penta, hexa, and so on. With the position, if you number it from left or right, you get the double bonds located at 1 and 3. Hence, the complete name would be buta 1, 3 diene. Understood?
Yes, sir.
Any doubts up till here? Yes?
No.
No.
Okay. So we'll stop here. You can practice the same examples as per the discussion, plus the assignment which has been given. You can start solving them. I'll send the solutions by tonight. And if any doubts are there, we can discuss it in the class. Fine? Thank you.
Yes, sir. Okay.
Bye. Thank you, sir.
Bye. Bye.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome. Yeah, any doubts? Okay. We'll move to the next examples from the NCRT. Problem 8.8. The first example, CH3, CH2, CHOH, CH2, CH2, CH with a CH3, and CH2, CH3. So as I have given the thought process, the longest chain needs to be selected. So here there is only one functional group, that is OH, and containing the OH, the longest chain is of 8 carbon atoms. And as we select the longest chain, I get two information. One is about the functional group and the other is the branch or the substituent. Lowest numbering rule says that number the chain such that the functional group gets the lowest possible number. In that case, the numbering will be done from left to right. So there is a child or a substituent of methyl at the 6th carbon, so 6-methyl. Parent of 8 would be oct with a single bond in, and the alcohol at the 3rd position, that is why 3-ol. 6-methyl octane, 3-ol. Next, we have CH3, CH2, C double bond O, CH2, C double bond O, and CH3. Observation, it's the compound with two ketonic groups, or I can say one functional group repeated twice. So both are to be included in the parent chain. And as we discussed, for one functional group repeated twice, we prefix it with di with the ketone suffix on. And the parent of 6 would be called as hexane, to be written completely without dropping the word e. And numbering, as per the lowest numbering rule, would be done from the right hand side, with ketones getting the position 2 and 4. Hence, it will be 2, 4 dione. Then I have CH3, C double bond O, CH2, repeated thrice, and then COH. Again, to name the compound, observation, two functional group. One is the acid and other is the ketone. So polyfunctional compound, you have to think about the priority. Priority goes to the COH. Once again, this becomes the main functional group, for which we'll pick up the suffix from the table, and the ketone becomes a substituent, for which I will be using the prefix. And if you observe from the table, the prefix for the ketone is given as oxo. The prefix is oxo. So applying the rule, the longest chain is the complete chain of 6 carbon, including the carbon of the COH. Numbering is with respect to the main functional group, hence we need to do it from the right side. 1, 2, 3, 4, 5, and 6. So completing the name, it's 5 with the ketone oxo, hex with a single bond hexane, and the oic acid is the suffix at the first position. That is why 1 oic acid. Now the 1 oic acid for carboxylic acid is a default position. Whether you write or don't write, it's okay. Both are correct, both are acceptable. Next we have CH triple bond C, CH double bond CH, and CH double bond CH2. Observation, it's an organic compound with a triple and a double bond together. Such compounds are called enine compounds. En for a double bond, ine for a triple bond. We replace the ene ka e by the word yne to get this name enine. Now for enine, there are some more important rules to be understood. So let me have two examples to discuss the numbering rule for enine. Okay. For enine compounds, the first rule is you have to number the chain such that the multiple bond gets lowest number. First multiple bond, whether it is double or triple, doesn't matter. You have to number it such that the first multiple bond occurring from the left or the right gets the lowest number. Look at the fifth example. If I number from the left hand side, my first multiple bond is the double bond occurring at the position number 1. And from the right, my first multiple bond is the triple bond, which is occurring at the position 2. The rule says number the chain such that the first multiple bond gets lowest number, hence the correct numbering will be from the left hand side and not the right. So that's the first rule. Second rule is if you are getting the same numbers from both the sides. Sixth example. If I number from left, I get double bond at first. If I number from right, I get triple bond at first. In that case, there is a tie. And the tie is broken as per the priority order. And the priority goes to a double bond. That's why the correct number for this enine would be from the left. Likewise, for the fourth one, triple is at the first and double is also at the first. Priority wise, double gets a priority. Correct numbering is from the right side. Now let's name this compound. So for the fourth compound, you have two enes. So you'll write diene, and you have one ine, so just ine. And as I said, whenever the double or triple gets repeated, the parent word root has to be added with the letter A. Hence, it should be named hex A. And the dienes are at position 1 and 3. The ine is at the fifth position. Complete name hexa 1,3-diene 5-ine. Fifth and sixth are easy now. Parent is of hex. Ene is double bond. Ine is for triple bond. And the position is 1 pe ene 4 pe ine. Next is but. 1 double bond ene, 1 triple bond ine, 1 pe ene and 3 pe ine. That's it. So these are the enine compounds for which two rules related to fifth and sixth examples were important. Thank you.